Well, good morning, everyone, and welcome to our webinar, 5 Red Flags, Exposing Hidden Issues in Your Dev Team. I'm Jamie Smythe, the CEO of the Smythe Group, and I'm happy that you're joining us. This webinar is designed for business leaders and startup founders who are vested in the success of their software projects, but they might often feel uncertain, possibly because they're not developers themselves. Have you ever felt like something was off with your software development project, but maybe you couldn't pinpoint it? Maybe it was the pace of progress. Perhaps it was the quality of work, or it could be the communication with your team. You sensed these issues, yet you couldn't put your finger on the root cause. Today, we're not only here to help you identify these unsettling feelings, but also equip you with the knowledge to articulate them effectively. Understanding the why and hows of these problems in software development can improve your methods. So we will cover 5 concerning red flags by using 5 stories that will demonstrate each red flag. The first story is the collision. The second is the launch after the Berlin airport, then the Ford Pinto, and then the secret recipe. Each of these stories will highlight a red flag, explain how you could detect it, how it impacts your business, and most importantly, what actionable steps you can take to address it. By the end of this webinar, I hope that you'll have more confidence to ask the right questions to identify these problems and then counteract them by applying the suggestions we'll talk about. So let's get started. Johannes has the first red flag story, the collision. Tell us about that.
Thanks so much, Jamie. Well, yeah, we have story time this morning, and we want to start with our first story. So just imagine you are aboard a beautiful cruise ship, like this one, the Andrea Doria. And you just had a nice dinner, you enjoyed some music in the lounge, and now you retire to your cabin. You're looking forward to coming home the next morning. You're in the bathroom brushing your teeth, and all of a sudden you hear a deafening bang, metal screeching, and you all of a sudden feel ice cold ocean air on your skin. You run out of the bathroom, and to your horror, you see that the exterior wall of your cabin has been ripped off. The bed and your spouse have completely disappeared. This terrible incident happened on July 25th, 1956, to Brooklyn resident Walter Carlin. What had happened? Well, low visibility led to a collision that ultimately killed 51 people. Thick fog and misinterpreted radar signals led to 2 ships making bad decisions. They went full steam ahead, although they didn't know where they were, and they didn't exactly know where they were heading. And that's our first red flag. It's low visibility. Low visibility kills. Sadly, there are many incidents where it killed people, but it can also kill projects too. As the captain, you need to know where you are at any given moment in time and where you're heading with your project. So how can you detect if low visibility is a problem on your project? Well, simply you can ask yourself one question: can I see? Can I see for myself what is being worked on without asking somebody? Can I see the source code that has been produced for myself? Do I have access? If the answer is no, then that's a problem. And to be a bit more concrete, the tools we're talking about here are issue tracking tools, for example, that give you insight on what has to be done, what is currently being worked on, by whom, and what has been completed. That's like your GPS helping you to navigate where you are and where you're going. The second tool we're talking about is source control or version control software like Git, GitHub, GitLab, or other tools like that. Those give you access to the latest version of the source code. That's like the precious cargo of your software project. And it's a huge red flag if Either developers are reluctant to use such tools, or they're reluctant to give you access to them. It might indicate that they think they have something to hide. Why is this important? Well, it's your ship. So if you can see if you're on course, then you might collide with your project. And if you cannot access or own the work that you're paying for, it's like not having access to the precious cargo in your ship. And that's a problem too. So what can you do about it? Well, first of all, ensure that your team is using issue tracking software. And if you've never seen a software that kind of looks like this for your project, that's probably a red flag. So a software like this, an issue tracking software, helps you to keep track of what's going on where you are. Like we said, it's like your GPS. And even if just a single developer is working on your software, it's good to have this GPS that shows you where you are. You also want to ensure that your team is using version control software. It's an industry standard. Most teams use it. Services like GitHub or GitLab. And often the bigger issue is that you need to ensure that you also have access to this tool that is being used by your team. Again, it's your cargo. The software is what you're paying for. You need access to it. And don't take no for an answer. There's no reason why you shouldn't have access to the source code yourself. So you could even ask yourself right now, if I wanted to, could I log into a software right now and get a copy of the latest version of the source code? You want to make sure that the answer is yes, even if it's no right now. So to summarize our first red flag, it's low visibility. And you can detect it by asking yourself, can I see? Can I see what's being worked on? And can I see the source code? Now let's hand it back over to Jamie for the launch.
That's great. Thanks, Johannes. Let's talk about the launch. On January 28th, 1986, the Challenger tragically exploded 73 seconds into its flight, killing all of the crew members. The disaster happened because the O-rings in the solid rocket boosters didn't seal properly in the cold weather. The NASA engineers tried to stop the launch the night before because they knew this could happen. One of them told their wife, "It's going to blow up." But instead of saying this to management, the engineers used technical jargon, and management didn't want to hear bad news. So they coerced the engineers to launch anyway. This tragedy illustrates a crucial lesson. Clear, open communication is essential. But I see poor communication on teams all the time. And that's our second red flag. So here are some miscommunication patterns to look for. The first one is misunderstanding technical jargon. In the case of the Challenger, managers missed the point because it was veiled in technical jargon. They didn't see the impact of what the engineers were really trying to tell them. This happens all the time in software. Sometimes devs are so in the weeds, they don't think about how to communicate simply. And when non-technical leaders don't exactly understand, they can't make effective decisions. Second, unclear requirements. Trying to produce a developer requirements is 100% an exercise in communication. It's hard. A manager might have given requirements they think will create the solution they're looking for, but without feedback and communication, a dev might simply follow instructions, creating a feature that was asked for, but not completely misses the business goal. I know because I was that developer. Cultural and language barriers. Sometimes software engineers from other cultures believe that it's wrong to challenge assumptions, so they simply do what the boss says. Other times, because of language barriers, engineers might not understand exactly what the bosses are saying, but they're so scared to admit their confusion, so they do something, anything, to avoid admitting that they don't understand. Last, a lack of trust. a lack of trust. If the software engineers don't trust each other or their managers, they won't share information among their team. A good engineer will know where all the bodies are buried. They know what technical debt there is, and they know what could crash the system, but they may not feel safe to share that information. So why does this matter? As I said, making custom software is an exercise in communication. So success depends on how well we communicate. If a software team wants a great system, the priorities should be people, process, and then tools in that order. Most toxic software development teams that I've observed, they didn't have tool problems. Some of them had process problems, but the majority of the problems that I've seen were from the way their people communicated or failed to communicate. So what can you do with these miscommunications? The most important solution is to create psychological safety within your organization. You want a culture of open, respectful, and free communication because this will help you to create better software. Keep in mind that at some point, how we communicate is as important as what we communicate. A team that communicates with humility and empathy doesn't simply deliver information. They communicate to help others make decisions. Being free to ask questions, disagree, point out technical flaws, that will enable your team to create the systems that you need. Perhaps if NASA had created an environment in the 80s where engineers and managers could communicate like this, we would still have those astronauts. Peter Drucker famously said, "Culture eats strategy for breakfast." Now, I might add, it also eats process and tools. Our company communication is our culture. So, do you want to fix your software? Fix your communication. Do you want to fix your communication? Fix your people problems by creating a culture of honesty, respect, kindness, and transparency. This will help you build a software system that will last. So I know that we've been talking about collisions and explosions. So let's go on to the next story. And for that, I'll hand it back to Johannes.
Thanks so much, Jamie. So I currently live in Berlin, Germany. And in October 2020, a brand new airport opened here, the BER airport. And you would imagine that people living here, Berliners, would be proud of this new airport. But for some reason, the opposite is the case. It's kind of a sore subject to most people. Why is that? Well, let me answer that with a quote from the New York Times. It said, 9 years late and 4 billion over budget, the airport is already outdated. Ouch. So the opening was initially scheduled for October 2011, 9 years earlier. But then it was pushed back to 2013, 2014, 2017, 2018, finally opened in 2020. And the project was plagued by basically anything you can imagine, a series of technical issues, management failures, and oversight problems. So this is a prime example that shows that slow progress can be a sign of several underlying problems and issues. And that brings us to our third red flag, that slow progress. Software development is hard and it takes time. I know I'm a developer myself, but inexplicable slow progress is a red flag. How can you detect it? Well, it's pretty simple. Things just take forever and you don't know why. That's how you detect it. If you're unsure if that's the case with your project, you could ask yourself the simple question, what's taking time? Do I know what is taking time? And there are really three possible answers. The first one is, I don't know. I don't know why it's taking so long. And that's the most common answer. And you know the scenario, after weeks of work, there's just nothing to see. No progress you can see or understand. And sometimes there's one issue closely connected to it that you might have also experienced. that your dev team is giving you the feeling that it's a huge undertaking to install a new version of the software, even while it's still being developed, so that you can see it and play with it. That's also a red flag. The second possible answer to what's taking time is the wrong thing is taking time. Time is being wasted working on something that shouldn't even be built at all. Let's illustrate it. Imagine that you are in charge of a construction project and weeks pass and there's just no visible progress. So you drive out to the construction site and you talk to a worker there and you ask him, well, what are you working on? And he tells you, well, I'm making these door locks and it's kind of tricky. The ironwork, the locking mechanism to get that right, we have to make our own keys. It just takes a lot of time. How would you react? Maybe you would say, are you out of your mind? You're wasting time building your own door locks where you could go to the store and just buy them, or from a company that has been making these for 100 years or more? Well, in software development teams, sometimes exactly this scenario plays out, that there's a tendency to build everything from scratch instead of looking around and seeing if there's already ready-made components that can either be bought or more often than not, just used for free as open source. The third possible answer to what's taking time is the right thing. That's good. Your development team is taking time and effort to build on features that set your software apart from the competition. But if it always takes way longer than estimated, that's also a problem. Maybe your team has a hard time grasping the true scope of a task, or it might just need some guidance to improve their skills in estimating how long something takes. Why does this matter? Slow progress. Well, it's pretty clear. If your project is progressing slowly, you're burning through your budget faster. And it might also lead to missing deadlines that can erode customer trust and confidence. So that all sounds pretty dire. Well, what can you do about it? Well, you can simply ask your development team a few questions and then make adjustments based on the answers. One question you can ask is, are we using automated deployments? Another term for that might be CI, CD, or pipelines. And what that means is that a recipe is written once that describes how software is installed on your server or how a new version of an app is pushed out to a test flight or to the App Store. And that means that multiple times a week, maybe daily or multiple times a day, the current status of your software development can be installed without extra effort from your team. And that means that you can always see what's happening and you can watch the progress. Another question you can ask is, ask for explanations that you understand. Ask, why are these things taking long? Why is there a delay? And don't be afraid to keep asking questions. A good engineer can explain things in a way that a non-technical person can understand. And finally, you can ask, has this wheel already been invented? Do we really need to build this ourselves? Sometimes there might be a $59 license for a service that does exactly the thing that your dev team is spending weeks or months to build. Or sometimes there might be an open source project that can be utilized for free. So don't build your own door locks, buy them, or even get them for free if possible. So to summarize our third red flag, it's slow progress, and you can detect it by asking what's taking time. So now let me hand it back over to you, Jamie, for the Ford Pinto story.
Thanks, Johannes. The Ford Pinto. It was introduced in the 1970s, became infamous for a fuel tank design flaw that made it susceptible to catching fire in rear-end collisions. The issue was that Ford was more focused on cutting costs and getting products out quickly than on consumer safety. Investigations later found that Ford had known about the dangers, but decided that the financial cost of lawsuits would be less than the cost of redesigning the fuel system. What a shameful approach to quality control. And this brings us to our fourth red flag: frequent quality issues. So, frequent quality issues, how do you detect them? Well, bugs. Everybody gets bugs. But nonstop regression bugs show that the engineers don't know how to fix them properly, which show poor quality in general. In addition, a lack of automated testing will result in poor quality. If your developers can't tell you about the different kinds of automated tests they're writing, such as unit tests, acceptance tests, or integration tests, all of them are automated, there's a possibility that they aren't writing any at all. And this will definitely show up in quality. So why does this matter? Well, if bugs reach production, they can cause downtime. That can damage your reputation with customers and investors and create security risks. Even late bug detection can also frustrate your team. So what can you do about it? You need to identify and address quality issues sooner before they reach production. And here's how we can draw some lessons from Toyota, a leader in quality and efficiency. And the two principles that we're going to talk about are Ondan and Kaizen. These are Japanese terms. Applying these concepts will help us find the bugs earlier and fix them the right way. So the Ondan cord. In the 1970s, Toyota wanted to encourage employees to stop the production line if a problem was detected, so that issues could be fixed immediately, not at the end of the assembly line. The solution? They devised the Ondan cord, as you see on the slide. It's a physical cord that any worker could pull to stop the entire production line and address a problem. This process put quality in the hands of every worker, not just the testers at the end. The result? They started making better quality cars. How can we apply this to software development? First of all, you need automated testing. Pardon me. Human testers are necessary, but insufficient if you want to have frequent releases with good quality. Pardon me. As I said, human testers are necessary, but insufficient if you want frequent releases with good quality. Automated tests are immediately, they will tell you when there is a defect and how to pull the Ondan cord. You should also implement a CI/CD pipeline, feature flags, and have a dedicated dashboard that automatically displays critical issues. This will help you to create an environment where developers feel empowered to stop the work and address issues as soon as they arise. Now, I know it's really hard to retrofit your system if these principles if they aren't already in place, but they will save you from becoming a blazing Ford Pinto. Now, if you need some help, this might be the time to bring in some consultants, but it will be a worthy investment. Toyota also adopted a long-term philosophy known as Kaizen, which involves small, continuous improvement. It involves constantly looking for ways to improve operations. Toyota encouraged everyone from top managers to factory floor workers to adopt this mindset. In the context of software development, we can apply these principles to a practice where the developers actively factor and refactor their code to improve it immediately upon identifying a specific bug. And rather than merely fixing the bug, the developer should take the opportunity to examine and improve the surrounding code. And when they fix it, they should write an automated test to make sure that that bug does not regress in the future. Your entire suite of automated tests should be run automatically against your entire code base after every change in the master code repo. You also need to make sure that your developers are writing thorough automated tests. In time, this makes your code base cleaner, more efficient, and more maintainable. So, by adopting these principles from Toyota along with automated testing, you'll significantly reduce frequent bugs and build high quality, reliable software. So, let me now transition back to Johannes with the secret recipe.
All right, thanks so much, Jamie. It's story time again. So imagine you're the owner of a popular restaurant. People just love the food, they love the atmosphere. And on Saturday nights, it's hard to get a table. The line is around the block. But the chef that's working at your restaurant is the only one who knows the recipes. Nothing is written down. And you've noticed that when he's sick or on vacation, you can only really serve drinks and potato chips. Then one day, your chef quits. You try to hire another one, but no one can quite figure out how he made those signature dishes. So customers start complaining, sales drop, and eventually you have to close. What does this restaurant story have to do with software development? Well, it brings us to our fifth red flag, and that's knowledge silos. That means that vital knowledge exists only in the head of one single person. And knowledge silos in software development can put you in a similar situation and make your business vulnerable. So how can you detect if your project suffers from knowledge silos? You can simply ask yourself, who knows? Who knows how to install a new version of the software? Who knows how to release a new version of the app to the App Store? Who knows how to log into Google Analytics? If again and again just one single name comes up, you have a knowledge silo. And if that one person leaves and you already know that 90% of the knowledge will go with him or her, you have a knowledge silo. And here are some other symptoms you can look out for. One would be that nothing is documented. Nothing is ever written down. You just always have to ask a person to find out. Another sign could be that non-company accounts are being used for APIs and services you use. That means maybe your developer just uses his own account for Google Analytics or for some other vital service, and you don't have access to it. Or even if a company account is being used, does only one person know how to log into it? Or does the team have a shared way of accessing these credentials, or at least you have access to these credentials too? And another sign would be that certain things can only ever be done on one person's laptop or computer. Oh, you want to release a new version of the app to the App Store? Well, that only works on Linda's computer. That's the only way to do it. That's a red flag. Why does this matter? Well, it's pretty obvious. It makes you vulnerable, and if there's a bad actor with low morals in play, it can even put you in a position to be blackmailed by that person. And ultimately, it puts your company in jeopardy. So what can you do about it? Well, first of all, you can allow time in the budget and the estimate for writing documentation. Documentation exists both in the source code, explaining how vital parts of the source work, but maybe also in external documents that outline how certain procedures work. Anything vital, anything important to how the system works should be documented. And you can also foster an atmosphere of knowledge transfer and cross-training. That means that sometimes you might allot some time and allow two people to work together on the same task so that knowledge can be transferred between different team members. Another good idea is to have an onboarding document for new developers. So when new hires come on, They can follow a certain recipe to get their machine up and running with the development environment and can quickly become productive. And a practical way of what you can do is test this when a suspected knowledge silo person is away on vacation. Just go to another team member and ask, could you install another beta version on the server? Could you release another preview version of this app to test flight? Or could you log into Google Analytics and show me the latest stats? If the answer is always like, well, Bob is on vacation, I don't know how to do this, that's something that should be addressed. So in summary, our fifth red flag is knowledge silos. That means vital knowledge exists only in one person's head. And you can detect it and address it by asking who knows and then acting on it. So now let me hand it back over to Jamie.
Thank you, Johannes. That was great. So let's review our 5 red flags. First, think about the SS Andrea Doria collision that occurred because of low visibility. Demand access to source code, accounts, and establish a transparent ticketing system. Reflect on the challenger that exploded because of poor communication. Foster a culture of open, respectful communication and psychological safety. Remember the story of the Berlin airport and how it demonstrates slow progress. It was 9 years late and $4 billion over budget, and it was already outdated when it opened. Make sure that you're using an automated release process with CI/CD pipeline that will accelerate progress and quality. Recall how the Ford Pinto design flaw illustrates problems with frequent quality issues. Implement the principles of Ondan and Kaizen from Toyota. Use automated testing, CI/CD pipeline, feature flags to help you find and then immediately fix the problems in your software. Ensure your engineers to fix problems as they arise and seek continuous improvement through thorough testing. And lastly, consider the story of the secret recipe and how the chef that quit with the recipes and that caused the restaurant to go under. Knowledge silos put your business at risk. So make sure to document important information and share it with others that are trusted team members. Thank you very much, Johannes. Well, now we have a very special guest, and I have the honor to interview for a few minutes Ty Downing, the COO of SkyNav. Ty, thank you so much for joining us today. I know that you have hired and managed software development teams and you have experience, but can you just start by telling us for a minute about yourself and your role at SkyNav, as long as some background of what SkyNav does?
Sure. Well, first of all, thanks, Jamie, and your team to allow me to be on your webinar today. It's an excellent, very critical topic indeed. So thank you again. So a little bit about me. I've been in the tech industry. Specifically, I owned and operated a digital marketing agency for about 20 years. This predates Google, back when Netscape and Yahoo were the search engines. So and we've seen over the years a lot of shift in marketing online. We went through the entire social media explosion in 2008, but we hadn't seen a lot of movement until 5 or 6, 10 years ago with spatial computing, virtual reality products. And that's where SkyNav, you could say, was born, a new marketing experience. Essentially, what SkyNav is, it's a pretty powerful software that allows aerial to ground experiences using 360 high definition imagery to immerse people into whether it's a destination, a city, or even large scale applications. So the software is pretty complex, but it's pretty cool.
That's really cool. I like it. Thanks. So getting down to your dev team, I know last year you made a decision to make some changes with your dev team. What problems were you facing that were keeping you from reaching your goals?
Well, Jamie, we had quite a few problems, unfortunately, and the webinar you put on today really addressed most of the problems we had. And the goals we wanted really had to overcome these problems and issues. For example, some of the core problems we were faced with as business owners and leaders was, one was communication, and you touched on that beautifully. We didn't have that. We didn't have transparency. Unfortunately, with the dev team that we did have, there were falsehoods, there were communication gaps. There was even communication that we feel was very dishonest, and hiding things. I think it was mentioned in your webinar, we don't want to expect to know every bit of code, but we do detect things that are not accurate. So unfortunately, low visibility was happening with us. We just wanted them to show us, and that wasn't happening. So that was a big goal. Number two, again, commented on the webinar, was documentation. Processes. If somebody did leave, could somebody fill that role with documentation? It didn't exist, Jamie. That was really scary. So that was a goal of making sure we had those processes, whether it was daily, weekly, or when new components software was created, to have that. And then third was organization protection, establishing protocols that would protect our proprietary software. Just as simple as uploading to a repo. That was not being done. And unfortunately, as business leaders, we need to know that. Those are the things that do keep us up at night, because if a bus hit one or two of the members, there really went our potential software. So it was a crucial time, but we had to meet those goals to cover them.
Yeah. Yeah. Thanks, Ty. I get it. And I can sympathize. I've been there. So you made some changes. How did those changes impact your team's like performance and maybe your business outcomes?
Yeah, good question. So we're thankful that we did make some changes, and we did find a team. Actually, the Smythe Group was legitimate. And one thing I failed to mention before is that we didn't trust the previous team, and that's not good. We now have trust that our goals are being met, they're being exceeded, and that's refreshing. I think we were talking before the webinar that as business leaders, owners of companies like this or software, we don't want to learn code. We don't want to know Python or languages. We don't have time for that, but we do need to control our own platform, or we need to know what's going on to some degree, like the illustration of a captain, not knowing the cargo, or God forbid, not having the steering wheel, or not knowing the recipes. Those are things that we need to know. We have to know. And it was very gut wrenching to not have that security. So we could see we extinguished the flame, the Pinto. But at this point, Jamie, we can say that we can get back to business essentials. We can start building software and technology industry. We know these days, every 6 months it changes. So we haven't been able to add new features because we were so worried about the maintenance and the dev team. We don't have to worry about that now. That's the power of having the right team in place.
Yeah. Awesome. Yeah. Maybe do you have some advice? Do you have some advice to give other business leaders that might be considering maybe some improvements with their dev team?
Well, as somebody speaking from the shoes and behind the table, you could say, of a business leader that owns a software company. You mentioned a business leader. Well, that's the point, Jamie. We have to lead. And leading in this role means you're shaking the hands and speaking to the stakeholders. You're speaking to the investors. You're being a visionary. You're looking at P&Ls, right? We do need to make time to see what's under the hood. But like I mentioned, my advice is, you don't need to learn code. You just need to learn the basics and learn. I think Johan said it best. A good programmer, dev team can explain this to somebody in my role in a way that makes them feel comfortable and a way that they can trust them. So hire the right team. That's the biggest advice, and vet them. So whether you are in the vetting process now, you're looking for a dev team, or you already have one in place, before that spark turns into a raging fire, definitely create a plan of action and really follow the outline of this webinar today, and match that to your current dev team or the future dev team you'd like to have, those 5 points. And lastly, and again, you guys mentioned this beautifully, demand answers. It's your software, so you can finally get some sleep at night.
Yeah, well, that's the goal. That's the goal. We got to get Ty some sleep. Thank you so much for that, Ty. I really appreciate your valuable time and your insights. So how can reach out to you? How can people reach out to you online?
Yeah, sure. Just reach out to me if you'd like any other background or information on LinkedIn, Ty Downing. Just simply type that in. You should see me with SkyNav, or drop me an email, ty@skynav360.com.
That's fantastic. Thank you so much, Ty.
Yeah.
Well, friends, we have covered a lot today, from the 5 red flags along with Ty's story and experience. I hope that you leave today with some actionable ideas. Thank you so much for joining us today. I hope that you learned something. If you need help addressing with some of these red flags in your dev team, please don't hesitate to reach out. Have a great day. See you next time.